Okay, everyone, welcome back to our module on data management, visualization, and reproducibility. Today we're going to be talking about data exploration and visualization, and our first lecture will be on data transformation. So we're back to data manipulation, and just a reminder that once we have tidy data, we may need to update its format, create new variables, filter out other variables, etc. You're not always done once you have tidy data. And so again, we want to practice doing all of our manipulations in R because this preserves our data integrity. And it does take a lot of time, but it's worth the effort. Just want to remind you of that. And also just remember to Google anything that you don't know. So we're back to our visualization here of our process. And so we're moving on to the transform section where we're exploring our data. And we're going to talk about today some useful functions for transforming, and they're listed here. In this lecture, we'll be using partial data from a study by Cravens and Boyle in 2019 on morphological data of bats, so check out the link if you're interested in the full paper. And so just a quick rundown on the dataset bats.csv. And you have your age of bats, so they're either adults or juvenile. You have their sex, male or female, their condition, their RFA, which is the length of their right forearm, their body mass, the moonlight, and the average temperature. And so the first function we're going to talk about is filter, and this subsets observations based on their values. So the first argument is the data frame that you want to filter, and the following arguments are the expressions for how you want to actually filter the data. So say you want to only look at female bats, this is the function you'd use, and you can see the resulting output is just the female bats. And you can combine, so you can look at multiple conditions. So you could also look at only male bats with a mass above 15 grams. And so here again, you use filter with your data frame, and then you have all of the conditions that you want with separated by commas. So sex equals male and mass is greater than 15 grams. And don't forget that if you want to use the pipe, you don't have to specify the data frame if you put the data frame first. So you can say take your data frame bats, then filter based on where sex equals male and mass is greater than 15 grams. And so another thing that you'll use pretty commonly with filter and other transformation functions is our Boolean operators, And this helps you select various sets. So in these Boolean operators, the ampersand symbol is and, the pipe stands for or, and the exclamation point stands for not. And just a quick note that filter excludes rows with NAs for the variable specified, so just so you know. And so I've included this figure from the R for Data Science website and book, and it just sort of demonstrates what all the Boolean operators do, what the different subsets are, so you can sort of see it more visually. And so here the left circle is X, the right circle is Y, and the shaded region indicates the given subset selected by the operators. So you can use your filter function with your Boolean if you want. So before we had looked at bats that were just male and greater than 15 grams, and we'd separate that out with a comma, but you can also do this with Boolean operators. And so in this case, you would replace that comma with an ampersand, and you get the same result as the last. Or for example, say you want to take this set of bats that are adult females. So here you then want to look for the set that are female bats and are age A, right? So adults, and here you can see the resulting output. Or say you want the set of bats that have either a condition NR or L. And so here that would look like this, where you filter where your condition is NR or with the pipe condition L, and here's your resulting output. And so arrange is another really useful function, and it helps you sort your data in the order you want. And you can arrange by more than one column if you prefer, and this will help break ties when they occur. So here we've arranged our full bats data frame by average temperature, then condition, then RFA. And as you may have noticed, the arrange function sorts by both ascending numerical and ascending alphabetical order. But you can flip this if you want to descending order, right? So highest to lowest number or Z to A using the Ds function. And again, another note that a range always puts your NAs at the end of your data frame, no matter if you're sorting in ascending or descending order. So say you want to flip that arrange we just looked at and do everything in the reverse descending order. You just put the D's function around your three column variables that you want to look at, and here you can see it's completely flipped from the last data set. And select is another useful function if you're ever trying to pull out certain columns. So for example, you say you want to select the columns just for sex, moonlight, and mass. Here you would just use your select function, and then you just get your resulting data set that does not contain the rest of the columns. And mutate is a function that's also super useful and helps you create new variables in your data set from existing ones. And so mutate you'll probably use this quite frequently, and mutate, instead of doing it in Excel or something, it's really useful and easy to do in R. So mutate always adds a new column at the end of your data set. And so say you want to know the ratio of each bat's right forearm length, the RFA, to its body mass. Here you would just use your mutate function and specify the name of the new column you want, and then say that that's equal to the RFA divided by the mass. And here you can see the resulting column for ratio is now included in the data set. And say you want to create a new data set where all you care about is this new variable, because you have so many columns in your data that you just only want these new ones that are actually important. You can use the transmute function, and that just gives you simply just the ratio. So there's a lot of useful functions for creating new variables out there, and I'm only going to list some here, but please use Google if you're ever looking for something specific. But you have your arithmetic operators, pretty straightforward. You also have log functions, and don't forget that log is the natural log, and then you have log base 2 and log base 10. You can look at the lead or lag of a set. You can look at cumulative things, so the cumulative sum, the cumulative product. There's lots of examples of these. You can also look at your ranking, so what's the row number? You can rank by row number, percent rank, min rank. So there's a lot of things out there, so really just look up something if you're unsure, because likely the function exists. And summarize is super useful. It's one I use quite a bit. And it allows you to collapse parts of your data frames to a single row. So you're basically summarizing your data based on specifications. So say you want to get an average mass of your bats. You can use summarize, where you say the average mass is the mean of your previous mass column, and then you can get the resulting output. It was just the average mass of all of the bats in your entire data set. And so these kinds of summarizations can be really helpful for graphing. They can be really helpful for exploratory data analysis. And if you want to summarize by multiple groups, then use your pipe. So take your bats data frame, then group by sex, and so male and female, and then summarize by the average mass, which is the mean of the mass for those groups of sex. And so here you can see that you have an average mass for your female bats and an average mass for your male bats. Or if you want to, you can make this as complicated as you want. So if you want to group by both age and sex of your bats and then summarize for the mean mass of them, you can see now you have male and female adult and juvenile bats and their average weight. And here I'm listing some really useful functions that you may use quite a bit in Summarize. And again, there are lots, so look them up, but here are some that I thought might be super useful for you just to have written down. So you can have some exploratory statistics like your mean, your median, standard deviation, or interquartile range. But you can also get measures of your rank position, so the minimum. You can look up your quantiles. So here, I use this one quite a bit. So here you take your data frame and then look at whatever set of quantiles you want. So here I want to look at the 0.05 and 0.95 quantiles, but you could look at anything, 50%, 25%, etc. You can look at your max. The first in a set, you can look at the nth. So take your data frame and I want to look at the second value in your variable. You can look at the last, etc. You can also do counts, which I think are really helpful, and that gives you the size of your current group. You can sum things if you want to do make sure you do is.na if you want to make sure you not to include NAs. And then a new function that I just learned about, which I think is pretty useful, is this ndistinct, which is the number of unique elements in X. And I used to use a very complicated way to solve this, so I think this is a really nice function, this ndistinct. And so what you're going to be doing when you're transforming your data and exploring it is that you just want to combine a lot of these functions to see what your data are telling you. So say you want to summarize by group and arrange by mass. Here you can, just go crazy using the pipe and looking at your data frame. So here you're grouping by sex, age, and condition, and then summarizing for your mean mass, and then arranging it in a way that makes sense to you.